We proposed OIE. Credit card fraud detection often involves detection anomalies. While traditional systems only detect anomalies, the OIE system also explains and summarizes findings, helping users address fraud faster. This is our proposed OIE. Outlier Interpretation Engine System. It first uses the LOF algorithm for anomaly detection, then utilizes decision trees to generate interpretable rules, helping users understand and evaluate each anomaly through rule summarization. The OIE system employs two optimization objectives. The length objective simplifies the rule while the entropy objective ensures classification accuracy. Finally, we integrate these two objectives into one function. However, the length objective grows too quickly, causing premature termination of optimization. How to balance them is the question. We introduce the stabilizer to address this. M is added to the optimization function denominator, dynamically adjusting to balance both objectives. Its value is calculated by the boundary stabilizer. For complex datasets, OIE adopts a data partitioning strategy. The optimization objective includes two parts. First, the error objective minimizes classification errors within each region's decision tree. Second, the locality objective ensures data points within each partition stay close to the partition center. The final OIE objective function combines these two objectives, balancing them through parameter lambda. The OIE system workflow begins with user data upload. Each data record contains multiple attributes with corresponding values, represented as feature vectors x1, x2, xn. Next, the system performs initial clustering, dividing the data space into n regions. This partitioning strategy enables more efficient handling of complex datasets. Third, the system generates decision trees for each partition to explain the anomaly detection rules within that region. Fourth, the system calculates and ranks F1 scores for each partition. Since C3 has the lowest score, it is split into C3 and C6, generating corresponding decision trees. This process iterates until all regions reach expected performance levels. In this demonstration, we showcase how OIE processes outlier detection tasks. In the Settings section, users can configure detection parameters through the system interface, including F1 score threshold, maximum rule length, outlier ratio, and select appropriate outlier detection methods such as LOF, isolation forest, or one-class SVM. Here we choose the default system settings. Users upload their data to the system and click the Process button, after which they can preview the data structure and content in the Data Preview section for validation. Once processed, users can examine key performance metrics in the Cluster Performance section, such as F1 score, rule length, and number of rules, while visualizing clustering results through scatter plots in the Cluster Visualization section. When users hover over any data point, the system displays its coordinates and cluster membership. Users can view either overall cluster performance or focus on specific cluster details. Simultaneously, the system generates and displays clear, readable rules in the Generated Rules for Selected Cluster section, showing specific rule content for each cluster. In the Rule Tree for Selected Cluster section, the system visualizes logical relationships between rule conditions through a tree structure, where users can hover over leaf nodes to view specific rules. The rules shown beside the leaf nodes correspond one-to-one with the rules listed above. For instance, when selecting Cluster 6, users can see detailed information about this cluster, with cluster visualization specifically displaying its data points, while generated rules and rule tree correspondingly show the cluster's rules and decision tree. For users seeking to balance accuracy and rule simplicity, OIE offers functionality to adjust key parameters like F1 score threshold and maximum rule length. By fine-tuning these parameters, users can customize the detection process to maintain detection precision while ensuring rule conciseness and interpretability. In this example, by lowering the F1 score threshold and maximum rule length, we can observe that the generated rules are simpler and more interpretable. Thank you for watching this video.